Hello, everyone, and welcome to my talk about reducing expenses on monitoring with VictoriaMetrics. Well, why VictoriaMetrics? Because I'm one of co-founders of VictoriaMetrics, of course. For those who are not familiar, VictoriaMetrics is an open source time series database. You can find it on GitHub. Sorry. Install it and run it for free in single mode or cluster mode, whatever. You can find me on GitHub or on Twitter. Let's get straight to the talk. This talk would be interesting for those who are working with monitoring, who are collecting specifically metrics. It will be touching only open source tools, and it will be most important for people who are familiar with Prometheus, Thanos, Mimir, VictoriaMetrics, basically all Prometheus-like time series databases. So how monitoring architecture looks nowadays. This is one of the simplest topologies where you have a monitoring system which knows about applications or cluster to monitor, and it periodically goes and scrapes metrics from them. This model, called pool model, it was popularized by Prometheus at first. It is also supported by VictoriaMetrics. The more classic way to deliver metrics is push model, when applications know about monitoring system and they decide when to push and what to push. This topology is supported by VictoriaMetrics from the very beginning, by Mimir, and starting from this year, by Prometheus, behind the feature flag. And this is more like mixed topology, where you can benefit from both approaches, from pull and push. So you have an agent to collect metrics as close to the application as possible. They pull metrics and then they push these metrics to monitoring. This is mostly used in high-loaded systems or in systems where you don't trust your metric source, when you don't trust your clients, so you want to put some artificial limits, specific limits to each agent, limit resources, rate limit, etc. But in all of these topologies, there are like four attributes, four factors which you will see on your monthly bills. These factors are CPU, memory, disk, and network. This is something for what you need to pay by the end of the month. And in this talk, we will discuss how we can reduce this. And there are two main approaches how to reduce expenses. Well, one is, the simplest one is just to take something which is a bit faster or more efficient with your resources. Or alternative approach is to be a bit smarter with what you already have, like to be a smarter driver using the same car. Okay, let's start with the first approach by picking something different. And this will be like a simple comparison of VictoriaMetrics and Prometheus, where we'll just drop and replace Prometheus binary with VictoriaMetrics binary. Let's see what we will have. So this is how I wanted to test Prometheus at first. So we have a benchmark suite called Prometheus RemoteWrite benchmark, and it is open source. You can try to use it, available by the QR code. And what it does, it consists of two stages, two aspects. The first one is ingestion load. Ingestion load needs some data to be ingested, and this benchmark uses Node Exporter as a source of metrics. For those who are using Prometheus, you are probably using Node Exporter as well. Node Exporter is a default exporter which exports hardware metrics from the instance, like CPU, memory, disk, whatever. So everyone who uses Prometheus is likely to use a Node Exporter. So we believe this is a good source for production-like data. So we have a VM agent which collects these metrics, and it pushes as fast as possible to the Prometheus RemoteWrite compatible storage, like VictoriaMetrics, Mimir, or Prometheus itself. And then there is a second aspect for read load. So below we have a ruler, a component which evaluates alerting rules for Node Exporter metrics. It does it periodically, it generates the read load. So we test two main attributes of the database, ingestion and reads. If you want to learn more about this benchmark, this is how we scaled it to generate 100 million samples per second, ingested into VictoriaMetrics, how much resources we spent, how difficult it to do. It's available by QR code. But after I did some tests and asked in Prometheus community, it turns out that Prometheus is not really efficient with accepting writes. But in the same manner as doing scrapes. So scrapes are much more optimized for Prometheus, and ingestion is like more a workaround. So I decided to tweak a benchmark a bit, and I threw away VM agent part, and I made both VictoriaMetrics and Prometheus to scrape the same target using the same scrape config. Both VictoriaMetrics and Prometheus, they are running on the same instances, same configuration of instances on the fixed versions, and both of them have limits of 3 CPU and 12 gigs of memory. And then there is a ruler which evaluates alerting rules for metrics they collect. The benchmark setup is the following. So we have 1,000 of node exporter targets. That's basically 1,000 of instances you want to monitor. We scrape it each 15 seconds, and we query alerting rules every 30 seconds. And also we introduce artificial churn rate. So, you know, in Kubernetes, churn rate is inevitable part, because when you change the application, pod changes its name, and this results in the constant churn rate. So in this benchmark, we have 5% of the churn rate every 10 minutes to simulate how things are going in Kubernetes. And yeah, the benchmark took 7 days of the constant load on both solutions, on Prometheus and on VictoriaMetrics. You see the ingestion was equal, and about 80,000 samples per second. In terms of active time series, VictoriaMetrics and Prometheus measure them differently. So VictoriaMetrics measure on 1 hour sliding window interval, and Prometheus, the green line, it has this sawtooth-like pattern, because in Prometheus there is fixed 2-hour intervals for collecting metrics in memory and then flashing them on disk. So this is how it looks like for installation with churn rate for Prometheus. In terms of CPU, both solutions behave like the same amount of usage of CPU, so no benefits here. But in terms of query latency, VictoriaMetrics is 16 times faster on average for doing the same alerting rules on the same data set. So you get improvement only for this. And also query latency for 99th percentile is not that impressive. It's only 2 times, but still you have an improvement for just replacing a binary. In terms of memory usage, VictoriaMetrics used 4.5 gigs, and Prometheus used 8 gigs. We compare in max values here, because max memory usage is what is important. So you get like 1.7 less memory usage for VictoriaMetrics for doing the same workload. And in terms of disk space used, by the end of the 7th day, VictoriaMetrics used 33 gigs, and Prometheus used 83 gigs for the same workload again. If you want to know more why VictoriaMetrics uses less disk space, please read an article from our CTO about improving Gorilla compression algorithm. It's very interesting. Okay, so a short summary. After 7 days of the benchmarking, Prometheus and VictoriaMetrics doing the same type of work on the same workload, we see that by just swapping a binary and keeping the same configuration, you get benefits in disk size occupied, memory usage, and query latency. CPU usage remained the same. You don't get benefit here. Okay, what about network? So this is the common topology for having multiple availability zones where you collect metrics, maybe different clusters in different zones. So you collect metrics here, and you don't actually bother about traffic, because usually cloud providers have free traffic inside the zone. But if you would like to build high availability solution, high available solution, you enter the red zone, because inter-zone traffic is not free. Usually Google Cloud or AWS will charge you for that. So this is where traffic starts to matter. And if you will use VictoriaMetrics for delivering metrics across the zone, you can get like 4 times a benefit in the compression of the traffic over the network, because VictoriaMetrics using enhanced RemoteWrite protocol. And if you will take a VM agent, which will write into Prometheus and into VictoriaMetrics, VM agent will understand that on the other side there is VictoriaMetrics, and it can turn on the enhanced Prometheus protocol, and it will compress data by 4 times, and VictoriaMetrics will be fine with that. So this is tweet from our, screenshot from one of VictoriaMetrics users who just updated to the latest version. And that's what they send us. So they get reduction in the traffic from 600 megs to 130 megs, which, of course, reduces their billing costs. You can also do more fancy stuff with improving network compression. So we're using that standard for compressing the network. So you can trade your CPU for compression ratio if you just pick higher compression levels, if you would like. You also can control the batch size interval to improve compressions, but these are complex things to set up. But what is more interesting here is that we can try to reduce entropy of the data to improve the compression. And I think this is usually overlooked by users. And now we enter this stage of being smarter about your data, being smarter driver. So this is one of the default recording rules for measuring average CPU usage for node exporter metrics. This rule here is a recording rule which calculates this average over time over CPU usage. And it produces 2 time series below for instance foo and instance bar. And now the question to auditory, can you say which instance consumes more CPU? Well, to do this, you will need to compare digit by digit, right? And thanks God they are aligned here. And probably you will stop comparing when you find the first difference. So this is like a meaning of significance of figures. Or a different experiment, if I will ask you, what is the average CPU consumption of instance bar? What will you tell me? You will likely tell me that it is about 5%, like 0.05, not all the digits of this number. So this is exactly what I mean by significant figures. In VictoriaMetrics, you can configure how many significant figures you want to keep. And this will transform the number above to the number below. You will still have this high resolution, but a bit less entropy in your data. And only this changes compression from 1.2 bytes to 0.8 bytes. It's about 30% of improvement for only keeping what matters to you. If you want more, check this article below or by QR code. I did experiment from migrating data from Prometheus to VictoriaMetrics and applying various tricks to improve compression. Okay, what else can make you a smarter or better driver? Well, understanding what's going on with your car under the hood of your database. So have you had such experience when you run a query and query takes like 10 seconds? Can you answer why it takes 10 seconds? Well, you can assume it is like a lot of data or not enough resources, but you can say for sure. You can only try to add more resources, reduce the selector to fetch less data and try it. In VictoriaMetrics, you have this trace query feature, which is similar to explain analyze from the timescale. And I will try to show you how it works, if internet will let me. Oh, okay, so we have a VictoriaMetrics user interface here, and here we execute the query calculating the number of gRPC calls over 5 minutes. Let's disable cache for the experiment, and let's try to get 30 days of data. So it takes about 4 seconds, or something like that. And how to tell why? Well, we use trace, and we execute it again. Now VictoriaMetrics collects all the details under the hood and sends you back. It also sends it as a JSON object, so you can programmatically analyze it. But you can also do this in the user interface. And here we see all the stages of query execution. And the blue line and dispersants, they are showing how much time you spend in each step. So there are the most important steps here. The first one is fetching match series, where we spend 200 milliseconds. If we'll check, these are actually RPC calls to VictoriaMetrics shards. So here we query VictoriaMetrics cluster consisting of 2 shards. And tracing says us that we spend like 200 milliseconds on querying data from each shard, in parallel, of course. So this accounts for 5% of the whole time spent, and 95% was spent on processing of the fetch data. And exactly we fetched like 11,000 of time series and 13 millions of samples to process. And I can tell you that VM select or query frontend, which does this processing here, has only one CPU. So it is likely if you'd like to improve the query speed, we need to do something about resources that we have. So these are slides in case if demo didn't work. Okay, so how to improve this query? Well, we can add more resources to the query frontend to give it more CPU so it can do things faster. Or we can be smarter about this data and do something interesting. But before doing something interesting, we need to understand what contained in this metric, which is so expensive, why we have 11,000 of time series, why we have so many data samples. And for this, we can use Cardinality Explorer. So this is another demo, which shows you what actually is kept, what metrics do you store in your time series database. Now we have a view of top 10 most expensive metrics in the database by the number of series. And our metric, gRPC server handle total, is here. It is on the 5th place. It has only 1,500 time series here because we're looking for 1 day. And on the query, we queried 30 days. Because of the churn rate, you get 11,000 instead of 1,500. So when we open this metric, we see that it consists of the following labels: gRPC method, gRPC code, gRPC service, and the most expensive label here is gRPC method because it has 63 unique values. And this also means that cardinality of your metric will be multiplied by the number of unique labels that you have. If you have 63 different gRPC methods, then you will have 63 multiplied by number of other time series for this specific metric name. So if we don't need this kind of resolution for this metric, if we don't need to know about these methods, and in our query we didn't, then we can try to get rid of them, and in this way we will reduce the size of this metric significantly and query will go faster. So let's see what we can do with that. So these are slides in case if query didn't work. So Cardinality Summary, Cardinality Explorer gave us an insight of the metric we want to explore, about why it is expensive, and it also gives us hints what we do with that. By the way, this Cardinality Explorer is available by default out of the box in all VictoriaMetrics component, and in next release you can query Prometheus with that. So you can specify Prometheus URL and get the same user experience. Okay, so how to improve this query? In Prometheus ecosystem, you will get an answer that probably you would need to use recording rules to pre-aggregate this metric before you query it. And the recording rule concept is the following. So you have a monitoring system, you have a data flow in, and then you can define a rule like please do sum of this metric, but without this label to aggregate everything. And then this rule will be persisted back to the monitoring system. This is the common approach. Everyone uses it in Prometheus, but the disadvantage of this approach is that in result, you will have both the original data and result of recording rules in your database. So in any, with definition of any recording rule, you end up with more data than before. This blows up your indexes, your memory usage. It may speed up some queries, but still you will contain more data after that. So what can we do better? Well, we can do this pre-aggregation before data gets into the database. And our metrics collector called VM Agent has this streaming aggregation feature, which allows us to pre-calculate, pre-aggregate data before data gets ingested into the monitoring system. So how it looks like. In VM Agent configuration, we can define a streaming aggregation config. We can specify which metrics we want to match. We can use metric name, we can use any time series selector with regexps. We can use lists here, so you can actually select anything you want here. We define time interval on which we want to do this aggregation. Output total means we working with counters, and without means we do this aggregation without this label. So it's similar like some gRPC servers without gRPC method. So just drop out this label, but we will still keep all the increases of the counters. And in result, VM agent will write this metric below, a new metric name, to the database. You can choose if you want to keep only this metric and drop the raw data. You can write both. So this up to you. But if we'll choose to keep only aggregated metric, we will get this reduce of resource usage afterwards. And here's how it looks like in action. So let's try demo again. So we have two queries here. We use 30 days. Let's disable cache first. And so the first query is over the raw data samples, and the second query is over this new metric name generated by VM agent. Let's see how much time it takes. So the first query took 4 seconds, and first query is responsible for this row query over row metrics, and the second query is over aggregated stuff, and it takes half of the second, so 8 times less time, and you get this improvement without adding more resources to VM select by just reducing the amount of data you process. Okay, cool. Summary of streaming aggregation. So it helps you to aggregate incoming samples before data gets ingested into the database. Prometheus has a similar feature request from 2018 or something like that, but it's still not there. In VM agent, you can already get it. Aggregation, this streaming aggregation can be used for scraped data and for ingested data simultaneously, and VM agent supports multiple ingestion protocols. So you can use Prometheus RemoteWrite, you can use InfluxDB protocol, you can insert JSONs, you can insert CSV files, whatever you would like. Streaming aggregation can be used as alternative to statsd and recording rules, and what is also cool, it is compatible with Prometheus, because you can aggregate data in VM agent and write via Prometheus RemoteWrite protocol to Prometheus itself, to Mimir, or to whatever else what supports Prometheus RemoteWrite protocol. Okay, another one, complexity penalty. This is more connected to the mental health and to the everyday working of the engineers. And yeah, here you see Cortex metrics architecture. So this is a distributed time series database governed by Grafana Labs some time ago. And that's how complex it is. It's really complex, and I've seen a few even memes on the internet about monitoring is simple and then showing this picture. So it's not very simple. Grafana Labs understand that, and they abandoned Cortex and they go on with Mimir, which is successor of the Cortex, when they changed the architecture of the Cortex and made it simpler, more adjustable at the same time. So here you have Mimir architecture, which still not very simple because it contains like 7 or 8 different components interconnected. And then you have VictoriaMetrics architecture, which consists of 3 components only. And I believe this is easier to understand what's happening here. Like you have ingestion pass, select pass, that's all. So why complexity can be painful? Because complex systems are harder to maintain. If you have 8 different components or 10 different components, the chances are that they will go off with higher probability than a system with lower number of components, lower number of moving parts, let's say. Complex systems are harder to educate about. Like, you will definitely spend more time exploring Cortex architectures than VictoriaMetrics architecture because it is a lot of knowledge to gather before you understand how it works. And complex systems are more expensive to scale. This is usually overlooked, but if you have only one component responsible for query processing, for example, and you are not satisfied with the performance, you can add more resources to this component and it will run faster. In the Cortex architecture, there is not only one component, there are like 3 or 4 interconnected components responsible for query processing. You can't scale just one, you need to scale multiple of them, and all of them have these different scale curves, so you will need to be smart about how you scale them, and all this results into allocating more resources and make it more painful. Okay, that's mostly all. So For Grafana dashboards that I showed about CPU memory usage for Prometheus and VictoriaMetrics, you can find a snapshot by the link here. Snapshot of the dashboard if you want to explore it, if you want to try yourself, try queries that I used on the dashboard. You can also find a benchmark repo if you would like to reproduce this test by the link. You can just simply run it in your Kubernetes cluster and read articles about saving network costs or improving compression. Also linked to streaming aggregation, and VictoriaMetrics Playground is the user interface which I showed you during the demo. Okay, that's all.
So, thank you very much. Are there any questions from the audience? Yes.
Hi. Thank you very much for the talk. You mentioned the removing of cardinality from your time series, but there's some times where you actually really need that. And we actually had instances where we are like cardinality of multiple million different entries. Have you any experience how VictoriaMetrics deals with that? Does it kind of cope well with that, or will it just kind of bog down like most other systems that are out there, like Influx, which will really, really, really go really slow?
Yeah, sure. So Influx consumes a lot of more resources for the same cardinality comparing even to Prometheus. So Prometheus is far more efficient in terms of high cardinality workload. There is no like a silver bullet for solving high cardinality issue. I don't know any database which solves this right now. But you can see how VictoriaMetrics uses less memory for the same workload comparing to Prometheus. So you can get a faster car if you use VictoriaMetrics in this term. But there is no silver bullet. I heard InfluxDB 3.0 was they solved the cardinality problem, but they don't say how, and they don't show any proofs of that. Yeah. Thank you.
Thank you.
And to the back.
Yo. Hi. You say VictoriaMetrics is fully compatible with Prometheus. So if I have an environment with many Prometheus exporters, it's easy to change?
Yeah, you just replace a binary. Or if you want to run a cluster mode, well, it is compatible with scraping. It is compatible with query language. You don't need to change your exporters. You don't need to change your configuration files. You don't need to change your Grafana dashboards. Everything will remain as it was. You just get another binary for running it.
Fine, thank you.
Brilliant throw. Any more questions at all from anyone? No? Okay.
Thank you.
Thank you once again, Roman Khavronenko. Thank you.